Got a submission here from Brolio, who is flying Betaflight 233. Unlike many people who are flying Betaflight 233, you are flying 1 kilohertz gyrosync, not 2 kilohertz. That actually will probably help us out a little bit because some of the 2 kilohertz traces are kind of hard to interpret. So with 1 kilohertz, hopefully there'll be something good to see here. You're also flying D-term cut of 0. That is a low-pass filter. No low-pass filtering on the D-term. So we'll take a look there. It is going to limit how high your D gains can go, although with the new filtering that Boris has put into Betaflight 233, he says that no additional filtering is needed on the D-term. So we'll see how that goes. Your main question, well, at least one of your main questions seems to be, are your P gains where they need to be? So let's take a look at that. And I'm specifically looking at roll for the moment. And overall, your roll P gain looks fine. We do start to see sometimes where it starts to kind of look oscillate-y. Here, as you raise the throttle, we start to see some oscillations come out, these sort of sine wave shaped movements. But much of the time, the P term is well behaved. And just because there's occasional oscillation during during more extreme maneuvers, that's not a problem. That doesn't necessarily indicate a tuning problem. And I've said this, I'm going to keep saying it. I'll keep going back to it. You got a race car, you're going to squeal the tires now and then. So a little bit of oscillation in the P term probably means that you've got the kind of sharp response that you want from an acrocopter. But then we get to something like this. And I really think this is a great example. I want you guys to compare this, look what the P term is doing here, with something like this. This is what I would call an example of the tires are squealing. We've got some oscillation in the P term, but it's not very large in magnitude. And if we compare that here, though, now notice that the oscillations are kind of dominating the P term. It's not like we've got the P term sort of going up and down and it's oscillating around its own line. Here the oscillations are really the strongest thing that we're seeing. So that's a hint that we may have excess P gain. If we keep looking, no, here's a roll, and this roll, we see a strong oscillation at the end of the roll in the P term. No oscillation at the beginning. The P term stays on one side of the line during the whole move, that's pretty normal. We don't see any oscillation in the middle of the move. But then as you return the stick to 0, now we see a strong oscillation. 1, 2, 3, 4 oscillations. So that's another hint that we may have excess P gain. And it's possible that you could try to tune this by increasing your D gain, but since you're tuning with D term cut of 0, there's going to be a limit on how high your D term can go. And if we keep looking, here's another one. And this maybe we are at 20 seconds. Let's just take a quick look back here. Hard prop wash. Yeah, that was going to be my guess, that was prop wash. So we're seeing here prop wash. And so we know that prop wash is the most challenging situation for the PID loop. So the fact that we see some oscillation here doesn't necessarily mean there's a problem, but it is pretty extreme, right? This kind of high frequency back and forth in the P term, that's a pretty clear indication to me, I think, that P gain is excessive. So we've seen 3 times now where there's an indication that P gain is probably excessive. So I think on roll, I'm going to say I would knock P gain down a little bit on roll. Let's take a look at pitch. What does pitch do? During the same prop wash, we don't really see anything. Let's just take a look through the trace and look at how active the P term is. And we can see during like a time like this, the P term is not very active. There's not a lot of high frequency components here. I'm looking for oscillations, for surging. I'm not seeing it here. Well, you're doing a roll. That's pretty normal that it would be kind of doing something there. Yeah. here's a flip. So yeah, there's oscillation pretty much throughout the flip. Now we might say, oh well, that means your P gains aren't right, but there's a wide variety of behaviors that can occur during a flip or a roll, and it's not necessarily the fact that we see these oscillations during the flip, like that's not the perfect sort of canonical example of what I would prefer a flip to look like, but that alone is not going to make me think you have a tuning issue that needs to be solved. So overall, your pitch P gain does not now look too high. What's going on here? Oh, it's a roll. It's normal to see the pitch P gain, or the pitch P term get a little active during a roll, and vice versa for a flip. So that's not too unusual. So yeah, pitch doesn't look too high. Maybe it could come up a little bit. Hard to say. Now here you say, I can see that as a move on pitch is being executed, there's shaking on roll and vice versa when rolling. But let's take a closer look at that, because the fact that the P term is going up and down, that's pretty normal. If you think about the copter flipping forward, the roll P term has to do some kind of crazy moves to keep the copter from rolling while the flip is occurring, and vice versa for a roll. So it's normal to see the P term on the opposing axis. In other words, if you're doing a roll, the pitch P term will kind of go back and forth. That's pretty normal. But let's look at the gyro. Are we seeing anything in the gyro when the flip happens? So here we're looking at pitch, but a roll is about to happen. And if we look at the gyro, we can see that the gyro is not zeroed out. But hang on, RC command is not 0, so that's not a good example. Let's look for a flip or a roll here. There's one. Okay, so here's another roll. Let's look at the pitch. Notice that the P term is going back and forth, and the gyro is oscillating. But I wouldn't call that a problem necessarily. I would just say that the P term is working to keep the copter stable while you're doing the roll. If you think about it, doing a roll about the roll axis while maintaining absolute zero motion about the pitch axis is actually asking a lot of the power system and the PID loop. So nothing about this jumps out at me as inherently problematic. This just looks like the P term is doing its job. Okay, so obviously, if you show me a video where you do a roll and you come out of the roll and you've pitched forward or pitched back significantly, that would be a different story. Although, being on 3S, that is going to somewhat limit what you can expect from your handling. That being said, you have a very light copter, so I mean you're definitely making the most of the thrust that you've got. On the other hand, you do have 1806 motors, which are not the most thrusty, so it could go either way. But overall, nothing jumps out at me in this log as inherently problematic. It's normal to see the P term and the gyro working on the pitch axis when you're doing a roll, and vice versa for a flip. The other question you've got is whether the D trace, the D term, looks like it's amplifying micro oscillations. So let's just take a look at your D term on these axes and see what's going on. One thing I'm doing is I'm looking at the magnitude of the D term, and we can see that the magnitude of the D term on pitch is very small. It is nowhere near the magnitude of the P term. And even if we look at a case where the P term is quite active, the D term doesn't become very active. Now you say it's on the edge of micro oscillations, and there is some high frequency components in here, and that's going to be the case because you're running D term cut hertz of 0 or D term cut of 0. You're disabling the D term filter. The advantage of that is that it means that the D term has very little latency relative to the P term. The D and the P term work best when they are in sync with each other, and the more you filter the D term, the more latency you get. And this was one of the main disadvantages of the soft filters that were first introduced in the early versions of Betaflight and are currently in CleanFlight 1.11. The soft filters are very effective at filtering but you have to filter the D term very aggressively, and that creates a lot of latency, a delay, or phase delay you could call it, between the D term and the P term. And that means that they're not in sync and they're not working together sort of optimally. What you're doing here by disabling the D term filter is you're allowing the D term to be as close in phase to the P term as possible with zero additional delay. The downside of that is that you get additional high frequency components and potentially micro oscillations if your D gains are too high. But the upside is that the P term and the D term are in sync. And Boris's research, which I'm just now going to repeat to you, shows that it's better to accept some high frequency noise and have the D term and the P term be in sync than to like get a super smooth trace but have them be out of sync. So this doesn't look too crazy to me on the pitch axis. It looks quite tolerable, quite acceptable. If we look at the roll axis, again, let's just sort of scroll through it. Here it's getting active. I don't see extreme high frequency components here, and yaw axis is typically where the D term is the least well behaved. But you've got your D gain very low on yaw, and so it's really not doing anything at all. So overall, I think your tune is close to good. I think you probably could reduce your roll P gain a few clicks, a few tenths maybe 1/10, 2/10, maybe 3/10, perhaps. Feel that range out and see how the traces look. It does seem like you're getting a few more oscillations on roll than I would prefer to see, but you know, how much tire squealing is acceptable or desirable? It all depends on the pilot. In pitch, I don't see anything that's really jumping out as extreme, and you could raise P on pitch. I think that addresses the things that you're asking about. Hope that's helpful, and happy flying.